Hello everyone, so today this video is going to be about the trigonometry you will need to be successful in calculus. The main thing we're going to use from trig in calculus is the unit circle and using that to evaluate exact values of the trig functions. So you will need to be familiar with these values in the unit circle and how to evaluate the sine, cosine, tangent, cotangent, secant, and cosecant functions. If you don't know the unit circle by heart, there are many tricks, and I can make another video about all of the tricks that you could use to memorize the unit circle. But some of the ones that I use, quickly are determine the quadrants and what values they need to be, positive or negative. So in the first quadrant, the cosine and sine are both positive. In the second quadrant, the cosine is negative and the sine is positive. In the third quadrant, the cosine and the sine are negative. In the fourth quadrant, the cosine is positive and the sine is negative. Also, something else I use to construct the unit circle is these angles right here. So I know that when I'm slicing the unit circle into pieces, this pi over 6 means that I'm just cutting the pi value, so from 0 to pi, into 6 pieces evenly. So that becomes 1, 2, 3, 4, 5, 6 pieces. So I know that that one's going to be right here. I know that pi over 4 is going to be cutting pi into 4 pieces. So we can cut it like that, like that, like that, and like that. And then for pi over 3, I know that I'm cutting it into thirds. So third here, a third here, and a third here. And pi over half is the same way. You cut pi in half, and that's where we get that. Something else that I use to remember the unit circle is I know that pi over 4 is going to be always, root 2 over 2, root 2 over 2. And sometimes I'm trying to determine, well, what is going to be the sine and cosine of pi over 6 and pi over 3. So something that I do is I will actually bring these all the way down. And then I look at the x value. I say, okay, well, cosine is the x value. This one obviously is 1/2. And then this one is more than 1/2, so that one would correspond to the root 3 over 2 value. So that's how I determine easily that the cosine of pi over 6 is root 3 over 2, and the cosine of pi over 3 is 1/2. And then I understand that I will have to put root 3 over 2 with that one, and then 1/2 with this one. Also, if you understand the first quadrant in the unit circle, you could use it to mirror the rest of the quadrants. And if you understand where the values are positive and negative, you could easily construct the unit circle just memorizing one quadrant. So I don't have the whole unit circle memorized. I just have the first quadrant memorized, and I recognize the patterns I need to do to create the entire unit circle from the first quadrant. Something else we need to know from trigonometry is the trig functions and their reciprocals. So we need to know that sine x equals 1 over cosecant x. We need to know that cosine x is equal to 1 over secant x, and that tangent x is equal to 1 over cotangent x. And tangent x can also be written as a ratio of sine and cosine, such as sine x over cosine x. So something else I want to say is that another thing I notice students doing is they forget to put their argument of the function. So they'll write sin, which you should know is a mathematical sin. So do not do that. You always have to have an argument attached to it. When you are submitting your work, you always want to make sure that you're using proper mathematical notation. So the other reciprocals are cosecant is equal to 1 over sine. Secant is equal to 1 over cosine. And cotangent is equal to 1 over tangent or cosine x over sine x. Using these identities are really important in simplifying or deriving other identities, so we want to keep these in mind when we're simplifying functions or even just evaluating trig functions. Something else we need to know from trig is information about what the graphs of the trig functions look like themselves. So I'm only going to show sine, cosine, and tangent because those are the most commonly seen ones, but you should also understand how secant, cosecant, and cotangent look, and I can make another video about how to get the graphs of those easily using the original functions sine, cosine, and tangent. So we need to know certain things about the sine function. So we know that it starts at 1, and we could use the unit circle to create all of these other points on the curve. So using the unit circle, you can easily construct a graph of it. You should know that the range is from -1 to 1. The period of sine is 2 pi, so that means we start here, all these values, now we're right back in the beginning at 0, and that's when sine starts all over again. We should also understand the symmetry. Sine is an odd function, so if we plug in some negative x into the argument, then we can bring that negative out front. So that's important. And we know that the sine function is odd, so it's symmetric with respect to the origin 0, 0. We should also be familiar with the graph of the cosine function. So we know that we start at 1, and using the values in the unit circle, we can work our way and construct a cosine curve. So we know domain's all real numbers, the range is from -1 to 1, so we're going from these values. Our period is also 2 pi, so it takes us 2 pi to get back to where we started. Something else we should know is the symmetry of the cosine function. Cosine is an even function, so if I plug in some negative x into my argument, then we can just say that its cosine of x is the value. And so since cosine is even, its graph is symmetric with respect to the y-axis. So cosine and secant are the two even functions. We should keep that in mind because it will help us to graph things easier in the future. So another important function for us to know from trigonometry is the tangent function. So we need to know that the tangent function's domain is all real numbers except pi over 2 plus k pi, where k is an integer. So we have these vertical asymptotes that occur every pi over 2 plus k pi. We need to keep that in mind when we're sketching a graph of the tangent function. Also, we need to know the period is every pi, so we start here at -pi over 2 and we go to pi over 2. So the tangent curve repeats every pi values. So we go from -pi over 2, and then we go to pi over 2, and then we start all over again at pi over 2, 3 pi over 2, and then we continue that pattern throughout. And then we also need to know that tangent is an odd function, and that means that if we plug in some negative x into the argument, that we could bring that negative out front. And then since it's odd, we know it's symmetric with respect to the origin, so that helps us to draw the tangent function. So something else we need to know from trig is inverse trig functions. We have to look back at the graphs of the original functions to be able to determine where the domain needs to be restricted to create an inverse function, because one thing we need to know about inverse functions, not only do we have to switch, if we have like a point x, y, the inverse would be y, x, so what we do is we swap the points, but we can't just swap all these points because the inverse function is 1 to 1, so we need to restrict our domain of sine to determine what our inverse function is going to look like. So what we would do is we would, we want to get the max range of values that we get, so what we're going to do is we're going to restrict it right here at -pi over 2, and then cut it off right here at pi over 2. So then we choose these values, and then we swap all of them in this area to get the inverse sine function. So now, since we are talking about inverse functions, I want you guys to know that this notation, sine inverse of x, is the same as arc sine of x. So arc actually means the same thing that this -1 inverse means. So you could be asked questions that say, evaluate sine inverse or arcsine, or take a derivative of arcsine. You need to understand that these mean the same thing. So the same is true for all of the trig functions. So you just need to know that arc means the same thing as inverse function. So now looking back to these reciprocal identities, we also need to be able to use common trig identities to simplify or see a function in a different way to make it easier for you. So you do need to know how to use these, but you also need to know the Pythagorean identity. So Pythagorean identity, which is cosine squared plus sine squared equals 1. And so with this, we could also use these identities here to come up with the other two identities. So if I were to divide both sides by cosine squared, we would get cosine squared divided by cosine squared is 1, plus sine squared divided by cosine squared is going to be tangent squared. And then 1 divided by cosine squared is going to be secant squared. And also, if we want to look at when we divide the original Pythagorean identity by sine squared, we get cosine squared over sine squared, which is going to be cotangent squared, plus sine squared divided by sine squared is going to be 1, equals, and then 1 divided by sine squared is going to be cosecant squared. So we could use these identities and just knowing the original Pythagorean identity to come up with two other identities without memorizing. So it's not very good to memorize all of these identities if you could easily derive them. You're not going to need as many identities from trig as you think, but if you understand the Pythagorean identities and understand the reciprocal identities, you're pretty much using all the identities you'll need. We might, in the later half of the class, have to understand, the double angle identities, but, we could always, refresh our knowledge of that later. So that wraps up the main things we need to know from trig to be successful in calculus. So I hope that you found this video helpful, and if you did, please like and subscribe, and I will see you in my next video.